This particular question is based on us launching this rocket, right? Let's have a look at this practical. So what did we see? We had a pressure chamber, and letting go of the pressure chamber happened through a pipe which had this paper rocket. So we did some work on it. That work got converted to kinetic energy, and the paper reached a height of 12.5 meters. Let's read the question now. Ignoring the drag force, we are not considering a complicated version, we're just taking a very simple version. So we're ignoring the air atmosphere. Calculate the potential energy of the paper rocket at the highest point. So when it reaches the highest point, it will have a potential energy, is it not? What is the initial velocity of the paper rocket when launched? So it will have a particular velocity. We'll be able to figure that out. Find the maximum kinetic energy of the paper rocket. Given the mass of the paper rocket to be 16 grams. So you can see here it weighs around 16 grams. Now, how will we go about doing this? Very first thing is, we have been given a rocket that we are launching from point A to point B. And we have this to be off with the initial velocity of more than 0, and the final velocity is equal to 0 at the highest point. And this highest point happens to be how much? Yes, this highest point happens to be 12.5, that is 125 by 10 meters. Okay, then what else? Then what do we have? Mass, we have, okay, mass is 16 grams, but I don't want grams, I want it in kg, so I'll divide with 1000. Remember, kg, k itself is 1000, so we are multiplying and dividing with 1000. Only then this will be balanced. This we are not converting anything, we'll just keep this as it is. I think we have written everything. Yeah, acceleration due to gravity is downward, that's g, which is 10 meter per second square. Okay guys, what else? Well, negative actually, but anyways, we have the working. What is the very first thing? Very first thing is calculate the potential energy of the paper rocket at its highest point. So potential energy at highest point. But what is potential energy? Which is equal to mgh. So mass is 16 by 1000 kg. Acceleration due to gravity is 10. Yes, we are not taking the negative value. This is only the magnitude that we need to consider. And the height happens to be 12.5, that is 125 by 10. So we have 10 and 10 getting cancelled. See guys, I'll show you guys a trick. 125 into 2 is 250. 250 can divide this, right? So that's how I'll remember that, yes, I can divide 1000 with 250. Since this is basically into 2 by 2. Okay, why is that I'm doing? 125 into 2 is 250. 250 into 4 is 1000. So 4 2s are 8 and 8 2s are 16. So basically the energy is equal to 2 joules. Right guys, the potential energy at the highest point is 2 joules. Again, please understand that I did all of this for simplifying the calculation. Yes, 125 per, of course it can divide 1000. But yeah, for me this is convenient. 25 into 4 is much convenient to think of. 250 into 4, sorry, than 125 into 8. Again, it's about convenience. Right? I could have shown into 8 only, but I just want to show you guys that yes, we can do all of this. That's okay. That is done. What is the initial velocity of the paper rocket when launched? Well, how will we figure this out? Initial velocity, though we don't know. Find the maximum kinetic energy of the paper rocket. When will we have the maximum kinetic energy? Right? To answer all of this, we have to figure out the law of conservation of energy. We have to get introduced to that. Only then we'll be able to continue. So here in this particular, as of now, we have not yet done. All the answers have not been answered. We'll be talking about B and C in time. Okay guys, you don't need to copy anything because we'll be redoing all of this again in the next set of videos. We'll be learning a new concept based on that, we'll be able to answer all of this in a faster way. I just wanted you guys to get introduced, okay, to the idea and how as of now we are not able to use this idea. We're not able to move to the next step, right? How will we figure out this? We don't have any information, is it not? Right? We need the velocity information, but how will we figure out the velocity information? Okay, that question will be answered with the help of the next concept, right? So don't copy anything. I'll see you guys in the next concept, and in the next concept we'll be learning all of this.